Hey y'all, happy Friday. Hope everything's going well. And this week of distance learning has been okay. I know it hasn't been ideal, but I hope it's been okay. Also, hope that everything went well with the quiz, that you were able to find it and that you were able to upload it okay. If you had problems with that, make sure you're reaching out and asking me because I'll be happy to walk you through that. Today, we're going to do a little short lesson on our next type of chemical reaction, which is our combustion reactions. Right? And the big thing to remember about combustion reactions is that anytime that you have a combustion reaction, that one of the reactants must be oxygen gas, right? So remember O2. Um, so when we combust something, right, we're basically combining that reactant with oxygen gas, and that is usually associated with a large output of energy. So most combustion reactions, as I say down here, are going to be exothermic. Now, for us, when we think about a combustion reaction, most of us think about a certain type of combustion reaction, and that's the combustion of a hydrocarbon. Now, a hydrocarbon is a compound that contains carbon, hydrogen, and sometimes it'll have an oxygen on there. And so when we get that, we combust a hydrocarbon and we get fire. And we're going to take a look at an example of that again, right? But you strike a match, right? Just ask Dylan, right? You strike a match, you light something on fire. That's a combustion reaction. And when you run down the hallway with it and you try to, you try to burn down a house, right? That's still a combustion reaction. And so combustion reactions, if you're combusting a hydrocarbon, now again, this is specific for combusting a hydrocarbon, you're always going to get the same reactants, or I'm sorry, the same products. You're going to get carbon dioxide, right, which is CO2, and H2O. So anytime, it doesn't matter what the formula of that hydrocarbon is, right, we react that hydrocarbon with water, and we always get, or I'm sorry, react that hydrocarbon with oxygen, and we're always going to produce carbon dioxide and water. Okay, so let's take a look at two examples, right? The first one is methane gas, right? So we all have heard of methane gas. Here we see methane being combusted with oxygen, and we're getting our CO2 and our H2O. Again, this reaction is exothermic, so delta H, and again we'll talk more about delta H, but delta H is negative, right, which means we're releasing energy, right? Now, if we change the reactant, and so in this case here we have ethanol, so C2H5OH, again, combusting that with our O2. Again, even though it's a slightly different formula, we still have a hydrocarbon. In this example, we have oxygen in there. We're still generating CO2 and H2O. So if I should ask you to predict the product of a combustion reaction, that's what I'm going to be looking for. I'm going to be looking for CO2 and H2O being produced. Now, there are a couple of different ways that we can say this, right? And so if I'm describing this particular reaction right here with methane, I could say, well, we burned some methane, right? And so if something is burned, that is implied that it's a combustion reaction. So if we are burning something, right, we are putting it through the process of combustion, and we are reacting it with O2. So whatever we're reacting with, we're going to react it with O2 if we're burning it. Now, that's a big difference as if we heat. If we heat something, normally this results in a decomposition reaction. So we're not burning it, we're just heating it up, increasing its temperature till it gets to the point till it starts to break down. So big difference in terminology. If we see burning something, combustion, but if we just heat it up, then we're probably going to get a decomposition reaction. Okay, so let's take a look at a great example of this. We kind of looked at this demo before, but I think it's worth watching again. And so let's take a look. So this is called a whoosh bottle, and now this one's in slow motion. So primary thing, right? And so we would do this demo in class. We would do it frequently. You can see we're applying that. Here inside the bottle is a mixture of probably ethanol and oxygen gas. And so it gets lit, and we can see that it's going all the way down, releasing lots of energy, releasing lots of heat. Now, question that I always get after this demonstration would be, oh, do it again, do it again, do it again, right? And so I would light a match and drop the match in, and the match would instantly go out. And the reason for that is because, well, all the reactants have been used up, right? And so now the bottle, instead of being filled up with oxygen and the ethanol, right, so this reaction here, it's filled up with carbon dioxide. And so most fire extinguishers are made out of carbon dioxide, and we spray that carbon dioxide, it's going to stop the combustion reaction from happening. All right, guys. So make sure that you do the daily task. It's going to just be a couple short questions, making sure that you watch this and understand it. Let me know if you have any questions. All right. Peace, love, happiness. Thanks for playing, and have a great weekend. We'll see you again on Monday.